Organizations are constantly seeking the powerful solutions to unlock the highest potentials of their data assets today. One such wonderful solution is Delta Lake. With its unique combination of security, scalability, and reliability, it has really revolutionized the way data lakes are being managed and run. The true power of Delta Lake does not just lies in its technology, but also in the best practices, and that is very important to implement it. To truly use the abilities of Delta Lake and push your organization to the unstoppable success, it is very, very essential for you to master these best practices. In this video, we are going to discuss the Delta Lake best practices, strategies, and techniques that can boost your data management and take it to the next level. Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment. Unleashing Delta Lake's powerhouse, mastering the best practices for unstoppable success. Here is the agenda. We will learn and understand what is Delta Lake and what are the best practices and how the Delta Lake functions. Then we will go through one by one 12 best practices, and these best practices we will discuss each best practices in great detail. So let's get started. Delta Lake, mastering the best practices. What is Delta Lake first of all? Delta Lake is an open source storage layer which brings the reliability and performance to the data lakes. And actually if you see, data lake is nothing but a storage layer in the cloud native space, whether it is Google, Amazon or Azure. But on the top of it there is a wrapper called Delta Lake which actually helps you to build the scalable, reliable data pipelines, and this works with your favorite set of frameworks and tools which you already use. Delta Lake allows a single copy of your data for both batch and stream processing, and it provides a incremental processing at a large scale, which means you can ingest and process the large set of data sets including petabytes of data. So traditionally we use different zones for data processing in Delta Lake, and let's understand these zones. There are three zones: bronze, silver and gold, and let's deep dive into why they are being used and what are their purpose. So bronze zone actually you push the raw data, unprocessed data, which is directly ingested from the different set of sources, and it is the data in its original format without any modification, and this zone is served as a first step or a foundation for the subsequent set of processing. Now the next step is silver layer. In silver layer we perform the data refinement, we prepare the data for the consistency purpose, we make sure that data is in good quality and reliability, and in this layer we actually goes the different set of transformation which includes cleansing the data, validation and integration. This layer also has such operations like removing the duplicates, handling the missing values or standardizing the formats and resolving the inconsistencies coming from the bronze layer. Then finally the data moves into the gold layer, where the gold layer is really optimized for analytics and consumption purpose. It actually enriches the data and aggregate the data for the specific set of use cases for which you are going to consume it. It has highest level of data refinement, which includes activities such as data modeling, creating facts and dimensions, creating derived metrics, and building data cubes or aggregate business rule calculations. And this gold layer provide a curated data which is well structured for the business use and then ready for the advanced analytics applications and machine learning applications, including Power BI, Tableau, or any other reporting tool for the purpose of the reporting. Okay, the first best practice is choosing the right partition column. And actually, how partitioning helps? Partitioning actually helps to improve the query performance. And why? Because it reduces the file sizes. And how it works is that we usually partition the table based on the columns which has a few distinct values, right? Like for example is that you have a country or region value, right? So countries or regions are few and very unique and distinct values. So what happen in that case is that it partitions the table, and when the query is fired, it actually goes to that certain partitions instead of going scanning all the different parts of the table. So when it goes to a certain partition, it can get the result and give you the query performance. And this is one example that you created a data frame, and then in that data frame you are actually partitioning it with the country, and then save it as a country people table. So partitioning really helps you to improve the query performance. So let's now discuss the best practice number 2, providing the data location hints. So whenever you fire a query, data lake tries to find out the column based on you are trying to filter it, and that filtering can be very expensive. So if you want that data lake need to go to those column which is frequently used for filtering, you can use Z order. Z order helps the data lake to arrange the file in such a way that whatever filtering criteria you are using, it is going to keep those particular values which is used for filtering in a specific locations, so that you have to skip the unnecessary data during the query execution, and it makes the query very fast. So this is the second best practice which can be used. Let's now discuss the third best practice, and which is called file compaction. So when you try to keep adding a new set of data in Delta Lake, and when you do it in a small set of data batches, what happens is that it actually leads to buildup of a large number of files over the time, because small data makes the files larger. And what happens with this approach is it actually negatively impacts the performance of the query, because it reads the data from these tables, and the small files, it need to go through the small files and then read that data. So the best practice is that if you can rewrite these files, very small files, into a smaller set of, because if suppose there are 100 files, smaller files, right, and if we compact them into 10 files, okay, and these 10 file sizes are larger, and in big data system, working on a larger file is easy than so many smaller files. So that way you can compact the file and increase the performance. And to compact the file, the command we use is optimize command. Optimize command actually compact these files, and then it uses the Z order indexing to skip the irrelevant data whenever you try to fire a query, which in turn improves the query performance. So let's understand this with an example. Like here we have a sales data table which contains sales transactions, and as in when the new transactions are getting added in a small batches, table actually becomes bigger, and then it accumulates large number of small files. That means there are lots of small files which is accumulated. So now if you use optimize command, optimize sales data where that date is less than current timestamp, Z order by sales type. So this way it automatically reorganize the data, and it rewrite these files into smaller file, and these like number of files are reduced and compacted, and then the one file becomes bigger, but the total number of files becomes smaller. And this way it helps you to improve the performance. Now the problem with compaction is that this optimize command is that it does not really delete the old files. So for old file deletion you need to use vacuum command, and vacuum command actually deletes the file which is no longer being referenced or used, and they are no longer needed by the table. So this also improves the query performance, because your old files are not getting accessed and they are not really touched, and you are able to clean it up. Okay, so the best practice number 4, replace the content or schema of a table. Sometimes you might need to completely replace a delta table, and there could be many different reasons behind it. Like, you may find that data which is already loaded in the table is incorrect, and there are lots of mistake in it, and you need to definitely replace that. Then second reason could be that there are data table structure change happened. Like, the table initially, suppose take an example, employee table used to have only two column, employee first name and last name, but now you want to add another column called age, and then date of birth. So then you need to definitely change the content or schema of a table and replace it with a new schema which contains the extra two columns. But what are the challenges with this? When you try to do this, you can either delete the entire directory where that file is kept, okay, or and after that you can create a brand new table with a new schema, or you can create it in a different location. But this approach is not really recommended because it has its own side effects. So what are those side effects? First is that deleting the large directory can be very time consuming, because you see that data is keep on coming, and there are data coming for 1 year, and then when you try to delete it, it can take at least some time, more than 15 to 20 hours or 24 hours sometime, right? And then deleting the directory also means that you are losing the whole set of data, and you cannot recover it back. Even if you by mistake, if you deleted it, you cannot recover it. Third is that deletion process is not automatic. Means, suppose somebody is trying to use that table and you are still deleting it, so while deleting itself somebody might be using it, and then he may not get the real clear result, good results. He may only get the result from the data which is still not deleted, so he may get an inconsistent result. So at the same time, first person tries to read the result, after 1 hour another person tries to read the result, both will get the different result based on the how much data is already deleted and how much is remaining in the table. So these are the challenges. And then these challenges, how do we avoid these challenges? So for avoiding these challenges is that if we use overwrite mode in the table, and then we use overwrite schema option to true, so what happens is that this method actually ensures the atomicity, okay, which means that everything happens at once, instead of doing incrementally, slowly doing it. It will happen all at once, and it will replace the whole table including the data and schema with the new data which you are trying to ingest. So this way you can avoid all these drawbacks of deleting the directory or achieving a seamless and you can achieve a very seamless replacement of a table. Okay, so best practice number 5, think before using the Spark caching. Spark caching actually stores the intermediate data or query results in the memory or on the disk, so that you can avoid recomputation of the same data and it can improve the query performance. But caching can actually speed up the queries on delta table, and we can store these results in the disk. But there could be problems with this approach. It may not be really effective for the subqueries, and those subqueries can definitely caching can really impact the overall performance, and then data consistency also. So Databrick always recommends that you have to be very cautious when you use Spark caching. And what are the disadvantages or the issues it can arise from the Spark caching? Thus, it is always recommended to cache a small and frequently accessed tables or partitions. Like, one example is that if you are using region, right, and regions are fixed and there is no much changes in the region, so those regions you can cache it, because this is not going to change, and you can we are going to frequently use it, so you can cache it. But if you always try to cache a tables or partitions which is frequently updated, right, and in that case people would try to access it, they will not get the consistent results, right? Then another guideline is that use the same caching level and storage format for queries on the same table and partition, so that there is a consistency, right? And always refresh or invalidate the cache whenever a new data comes, so that when somebody tries to use the same cache or the data, he gets the fresh data instead of getting the old and stale data. Best practice number 6, configuring Delta Lake to control the file sizes. So if you really want to understand the tuning of the file size, first we need to consider that how Delta table stores the data in the files. And Delta table actually organizes the data into file, and sizes of this file can definitely impact the query performance. So it is very important that we have to tune the file size, and then we have to balance the file size. So let's take an example, like suppose you have a very large file, and when you fire a query and these large files are read, and in that case, if the file size is very large, then it has to be loaded into the memory, and then Spark executor will read it. So this can create issue if the file size is too large. Another problem is that if suppose you have a very small number of files, right, and many small number of files. So if that is the case, then again it can be a problem, because the Spark need to go through many different small number of files. So the best practice is that you can club these small files, many number of small files into little bit larger files, so that you can reduce the total number of files. So there are these best practices which is used to strike the balance between different factors, and then you can adjust the file size. So first is optimize operation, which helps you to recommend the table larger than 1 TB, and it can consolidate it. Then so these are the different approaches, right? You can limit the row written in the data on the file, so that again it can adjust the file size. You can auto tune the file size based on the table size, and when to use that. And then there are some examples given here in the table, and the same thing is provided in my blog, so you can go through this and you can use it as a ready reckoner for your tuning process, so that you can achieve the balance on the file size, right? So you don't want to make the file size to be very big. At the same time, you don't want very small number of files and thousands of small number of files. That will also create a performance issue. So you can also set the target file sizes, right? You can optimize the writes, and in optimizing the writes, you can use merge or update with subqueries. So this way, these are the features. How do you do this? Delta.auto optimize or optimize write equal to true. So this is already given. This table is already given in my blog. Please go through that. It will give you an idea how to strike the balance. Best practice number 7, combine with low shuffle merge. So low shuffle merge was introduced in Database Runtime 9.0 and the newest version, that means the versions after that. Merge operation actually helps to synchronize the data between source and target table whenever you try to do the incremental load. And low shuffle merge actually helps you to optimize the performance of the merge operation for common type of workloads. How does it do that? Because it actually helps you to minimize the data movement and data shuffling, which is actually the root cause of all the query performance issues. So what are the benefits of low shuffle merge? Low shuffle merge reduces the data movement and reshuffling, and which in turn helps you to improve the query performance. It is very beneficial for large scale data sets, because large scale data set is where you have so much data moving from different locations, and that shuffling can be very expensive. And that way, it can also helps you to do the complex merge operations successfully. It preserves the existing data layout, which is already done by the Z order indexing. So that way you don't have to move the existing data which is kept in the large set of table. And it also helps you to keep preserving the data location, and that way it can reduce the data read which is happening on the queries. Low shuffle merge is by default enabled in database runtime 10.4 and above. And in the earlier sub versions, if you want to enable it, you can enable it with this option, spark database.delta merge enable low shuffle equal to true. Best practice number 8, manage data recency using time travel. So Delta Lake actually enables the concurrent reads and writes. That means there could be users who are trying to read the records, and then the records are directly written at the same time. And this really happens in the real-time processing, right? And there are challenges arises because the data which is being read at the same time, and and read and write at the same time. So there could be consistency related issues. So how do we solve these consistency related issues? We can use two options. First is time travel, or another one is a checkpoint. Time travel helps you to query the specific version of the timestamp of the data and then read based on that version. So I could say that when the data was read at that particular time, so that timestamp I want to know how the data was looking, right? And then the second option is checkpoints. Checkpoints are nothing but a snapshot of the delta table at a certain point. Checkpoints, what does it do? How does they store? They actually store a schema, partitioning, or file list, and this way you can create a snapshot and you can enhance the query performance. Checkpoint can be created with a create checkpoint command, and one example of this could be that if you have a sensor data which is keep on coming, and then you can create a checkpoint so that during that, when the time the checkpoint is created, you have that snapshot of the data. For optimizing the batch job performance, checkpoints are created to store the metadata. Because when you have batch data processing happening and you create a checkpoint, so that time the metadata is stored, and then you can refer that metadata or that particular data in the future. Checkpoint really helps you to improve the query performance, but it has its own limitations. The limitations are that they may not reflect the latest committed version of the data, and because they are not transactional, right? So you are not like you are keep on adding the transactions, and you cannot keep that keep updating the same data. Whatever is captured in the snapshot, this is only going to give you that much details. Checkpoints require a periodic refresh. So if you have created a checkpoint till yesterday, and if you don't refresh that with the today's data, then there will be a consistency issues. An obsolete checkpoint require manual management. So if checkpoints are old, and if you are not updated it will create issues. So you may have to manually update this, and or you have to enhance these checkpoint features. Best practice number 9, reducing the search space for matches. So we can improve the merge operation by performance by narrowing down the search space, right? So let's take an example. So let's take an example. Suppose you want to fire a query, and then you want to use the merge operation, and this is a query event.date, current date, and event country equal to USA. So the moment you narrow down this query for the country USA, what happen in this scenario is that the Spark will go to the USA partition, and it will do the operation on the USA partition only. And this will help you to minimize the conflicts, help you to faster the query execution, improve the performance and efficiency. So if you narrow down the search space, instead of making the search space to a larger set of data, if you narrow down it with the like this, the example given here, you can definitely improve the performance, and it will help you to faster merge operation, because it will go to that particular partition where the merge operation need to happen. And then it will also reduces the conflict, because people may, because if the search is happening across different partitions, then the chances of conflicts will be bigger. So if you are doing it in a narrow down approach, it will be less. So this is how you can use this. The best practice number 10, use Delta standalone libraries. So Delta standalone library is actually a Java library which is used to interact with the Delta table, okay, without even you are using the Spark. And how does it help? Because it helps you to enable the Java API access directly to the Delta table, and this you can use for if you are running or using a third party library or you are creating your own standalone application, you should use Delta standalone libraries. And these are the applications which can support its uses like AWS Athena, Apache Flink, Apache related tools, and AWS related tool, and even Azure Synapse Analytics. What is a bad advantage of using this library? Because Delta standalone library is very much optimized. It is a core part of the implementation, and it is very much optimized for reading and writing to the Delta table with a if you are using a non-Spark engines, and it serves as a low level and code, so that really it is very fast, and it is an open source library. And if you are creating a connector for different engines and those engines wants to use connection to Delta Lake, then you should always use Delta standalone library, because you are directly hitting the low level and then trying to access the Delta Lake. Obviously that is going to be very fast. Best practice number 11, use schema evaluation. So what is schema evaluation? Schema evaluation means that you want to enable the schema modification so that you can change the structure of the Delta table without actually breaking the existing queries which is already running, or existing pipeline which is ingesting the data. What are the advantages of it? You can add a new column, you can rename a column, or you can change the type of a column. For example, if suppose you want to change the type of a column from integer to character or character to integer, or you want to add a new column, you want to introduce a new column in the employee table, and in employee table the date of birth was not there, now you want to add that column, or you want to rename the name of the column, like instead of date of birth you want to rename it to DOB. So these are the examples of schema evaluation. So what are the uses of it? So when you set the merge schema option in the delta table, and I think I have already shown you this option, it helps you to create a schema evaluation, because your new schema will be merged with the existing one. You can also automate the merging of a new column from the source data to the target schema. So that if suppose in the source schema you have added 3 columns, now you want to make sure that target table also has these 3 extra columns. Or you can also convert the existing columns to the new types. So this helps you to achieve the schema evaluation. Now there are limitations of the schema evaluation. What are those limitations? First of all, it is not compatible with the nested columns like array or maps. It is not also compatible with the partition columns or Z order columns, right? And moreover, it is not compatible with the streaming sources or sinks. For that you have to definitely avoid it. It also has a potentially performance degradation, because it need to do it the way the new data is coming, and it need to accommodate that data. So the performance will be definitely problem, and it need to cast the data from older the old data type to the new data type. So there will be performance degradation. What are the guidelines of using the schema evaluation? Always utilize it when it is absolute necessary, and always avoid frequent data changes or schema changes, right? Always limit the schema evaluation to compatible changes, like adding the optional column or widening the numeric types to a larger numeric size, right? So always limit that kind of thing. There it is going to be okay. Always apply schema evaluation only to non-partitioned or non-Z order columns. If you try to add it in the Z order column, it's not going to be working. New schema, use always schema evaluation for batch sources and sinks. Streaming, you cannot definitely use it. So these are the best practices for schema evaluation. Best practice number 12, analyze your data using time travel. So time travel is a wonderful feature given in Delta Lake. And why it is important? Because with the time travel you can go back in the past and try to access the version of the data on a particular timestamp. What are the benefits of the timestamp? You can track and review the changes made on the data over the period of time. You can revert to the data in the previous version of the data if you require, because that way you can analyze the data, how the data changes happen from one part to another part, and then what are the changes happen on that particular day. This is very helpful for analyzation purpose. It can also ensure the consistency in the experiments, because sometimes you need to find out where the data corruption happens, and that way you can make sure that your experiments are consistent, and you can analyze it by accessing the data as it existed at a particular version or a particular timestamp. You can also help it can also be very helpful for populating the historical data, right? Because historical data, you can use the same logic and processing rule, and you can apply the same concept to the current data. So it can help you to understand how the data load happened, and that way you can use it for the current data as well. So how does this work? You can use version as of and then timestamp, or you can say that timestamp as of. These are the two clauses you can use. Like one example is select star from events where version as of 10, and this will be querying the table as it existed on a specific date, which is yesterday in this case. Select star from events timestamp as of date, and then current day 1. So this way you can find out the particular timestamp, how the data was. Timestamp, a good part of timestamp is that it can be used with the streaming queries, source on sinks, and you can replay that data or reprocess or the historical data with a different logic, because you can change that logic, because you are going back to that particular timestamp, and then you can apply a new logic to it and then reprocess the file. So this is very helpful, because in a large system, like in a big data system, if you have a data coming 100 days or 1 year, and you want to reprocess it, you want to analyze that, or sometimes you want to understand how the data is changing, so you can use this. But again, time travel only applies to certain extent. You cannot just use 1 year old data. So for that you may have to use a different strategies. Thanks for watching, and do not forget to subscribe and hit the bell icon.